Hello. Today we're going to talk about uniform circular motion, which is one of the most important kinds of motion in mechanics. This is the motion that arises when a particle moves at a constant velocity around in a circle. And we'll show why we say that such a particle has centripetal acceleration. Since the particle is moving with a constant velocity around in a circle, at time t1 the velocity vector might look like this, and at time t2 the velocity vector might look like this. So an important question to understand is, what is the acceleration of this particle as it moves around in a circle? So we eventually want to understand both the direction and magnitude of acceleration. In this video, we'll just focus on the direction. So we can denote the acceleration of this particle between time t1 and t2 as a sub t12. And now let's reason from first principles to try to figure out what this acceleration is. Well, remember that acceleration is the change in the velocity vector over time. So let's try to get some intuition for what the average change in the velocity vector between time t1 and t2 is. And to do that, we can take these two vectors we've drawn previously and subtract them. And intriguingly, when you take the vector v sub t2 and subtract v sub t1, you get this vector that looks like it's pointing towards the center of the circle. And indeed, that is the direction of the acceleration of a particle moving in uniform circular motion. It is towards the center of the circle. And this type of acceleration is called centripetal acceleration. Centripetal means center-seeking. And now you know why we say that a particle in uniform circular motion is undergoing centripetal acceleration, because the acceleration is towards the center of the circle. In the next video, we'll discuss the magnitude of this acceleration vector and how it varies with the particle's velocity and the radius of the circle.